the trailing zeros concept. Now see the 40th question. The number 2, 4, 6, 8 and so on up to 100 are multiplied. There is a natural number which is obtained by multiplying all the natural numbers from 2 to 100. 2 into, 4 into, 6 into, 8 into, 10 into and so on up to 100. 2 into, 4 into, 6 into, 8 and so on up to 100. Find the number of zeros at the end. Number of zeros at the end is given by trailing zeros. In session number 1, we discussed how to solve this kind of problems. 2 can be written as 2 ones are 2. 4 can be written as 2 twos are 4. 6 can be written as 2 threes are 6. 8 can be written as 2 fours are 8. 100 can be written as 2 50s are 100. 2 is multiplied 50 times. So this will be 2 power 50 into 1 into 2 into 3 into 4 and so on up to 50 factorial. Number of zeros at the end for a factorial is dependent on the power of 5. Because the power of 5's will be less than the power of 2. 5 tens are 50, 5 twos are 10. So 10 plus 2. Answer for this question will be 12. Answer for this question will be 12. You don't need to do it for the powers of 2. Starting with this question, there are some very, very good questions that we are going to solve it in today's class. This model we discussed in session number 1. So 50 factorial. Don't waste your time in doing the powers of 2. Next one. Read the question. Number of zeros in the end of. Number of zeros. If you observe, every second term is a multiple. Every fifth term is a multiple of 5. So n is given by 1 power 1, 2 power 2, 3 power 3, 4 power 4, and so on up to 100 power 100. 100 power 100. So every film is a multiple of 5. So the power of 5 will always be. Power of 5 is always less than power of 2. Power of 5. It is always less than power of 2. Only keep your attention on the powers of 5. So this will be n equivalent to 5 power 5. Next it will be power 10. Next it will be 15 power 15. 20 power 20. 25 power 25. 30 power 30. And so on up to 70 power 70. 75 power 75. And so on up to 99 power 99 into 100 power 100. 100 power 100. We have done the similar question in session number 1. Number of zeros at the end. How do you get the number of zeros? It is based on the power of 5's. So this will be 5 plus 10 plus 15 plus 20. 10 can be written as 5 into 2 power 10. So 5 power 10. 5 into 3 power 15. 5 into 4 power 20. 25 it is 5 square. So I will get 2 into 25. Are you all with me? Next again, 5 into 6. 5 into 7. 5 into 8. 5 into 9. And so on up to 70 it will be there. 5 square. 5 square is 75 is 5 square into 3. So I will get it is 75 power 75. It is 2 into 75. Next 70. 80 power 80. 80 power 80 means plus 80. 80 power 85. 85. 90 power 90. 95 power 95. 95. 100 will be 5 square into 2 square. So 2 into 100. I hope it is still here. From here to here, all will have single. So 5, 10, 15, 20. From 30 to 70, all will be again single multiples of 5. 5 6s are 30. 5 7s are 35. 5 8s are 40. 5 9s are till it has to be 75. 75 is a multiple of 25. Here 2 into 25. Here 2 into 25. 100 is 2 into 100. Why? Because 25 contains power of 5 as 2. 2 into 25, 2 into 75, 2 into 100. Remaining all will be single powers. Whatever you add it and get the answer, that itself will be the answer. I hope the idea it is clear. Very, very good question. You should not get intimidated looking at this question. There are 100 terms are there. Every second term is a power of 2. Every fifth term is a power of 5. So power of 5 will be less than power of 2. Only take the powers of 5. So if you solve like this, 10, 5 plus 15, 20, 30, it is 50. 25 2s are 50. So this will be 30 plus 70, 100. 65 plus 35, 100. 40 plus 60, 100. 100, 100, 100. 100, how many times I will get? 30 plus 70, 35 plus 65, 40 plus 60 we will get, and 50, another 50 will be there. So 4 into 100 I will get. Then 150. Then add this value. It's a simple addition. I hope the idea it is clear. Very, very good questions we are going to solve from here onwards. Find the number of trailing zeros in 150 factorial plus 200 factorial. Same question we did it in session number 1. N equivalent to 150 factorial. 150 factorial plus 200 factorial. So 150 factorial, if I take common, this will be 1 plus 200 factorial is 200 into 199 into 198 into and so on up to 151. These is a multiple of 5. 200 is a multiple of 5. 5k plus 1, it is not divisible by 5. 5k plus 1, it is not divisible by 5. So 150 factorial. For factorial numbers, number of trailing zeros can be given by power of 5. So 150 divided by 5. 5 30s are 150, 5 6s are 30, and 5 1s are 5. Answer will be 37. Answer will be 37. I hope you got the idea. Morning in the first session we discussed what happens if the factorials are added, factorials are subtracted, factorials are divided, factorials are powered. All the varieties we discussed. Next, 43rd. Now see here. Find the number of trailing zeros in this multiplication. Trailing zeros. So 2 zeros are there here. Here there is 1 0. Here there is 1 0. Here there is 1 0. 50. It is 1 0. 40 there is 1 0. These 1 0. And here there is 1 0. It is 1 1 1 0. And if you observe here, 2 into, what are the remaining digits other than multiples? 2 into, 3 into, 4 into, 5 into, 6 into, 7 into, 8 into, 1 into, how many powers of 10 are there? How many zeros I got? 2 plus 1, 3, 3 plus 1, 4, 5, 6, 7, 8, 9. So it is into 10 power 9. Now if you see here, 2 into 5, 2 into 5, 10, another 1 power of 10 we got. Into k into 10 power 9. 9 plus 1. Number of trailing zeros in this expression, it is 10. Very, very easy question. 2 zeros, 3 zeros, 4 zeros, 5 zeros, 6 zeros, 7 zeros, 8 zeros, 9 zeros. 9 zeros are there at the ending. 2 into 5, 10. One more 0 is there. Total 10 zeros, I will get it. Total 10 zeros, I will get it. I hope the idea it is clear. 43. Next, this question already, we did it in session number 1, similar pattern. If you observe, 44, keep a star mark, sir. Very, very good question it is. Very, very good question. Find the number of trailing zeros. Trailing zeros means number of zeros at the end. In the multiplication of, there is a series that will be given. The series is 1 into 4 into 7 into 10 into 13 and so on up to 100, and so on up to 100. The series is in AP. Morning we discussed the flow chart to solve this kind of problems. Step number 1, find the nth term. Tn equivalent to a plus n minus 1 into d. A is the first term. N minus 1 into d will be common difference, it is 3. So Tn equivalent to 3n minus 2. N can start from 1 and n can go up to 34. 34 3s are 102. 102 minus 2, 100. So n can take any value from 1 to 34. N can take any value from 1 to 34. Step number 2. Step number 2. If you observe carefully, 1, 4, 7, 10, 13, 16, right? Here one multiple of 5 is there. Next will be 13, 16, 19, 22, 25. But before you reach 25, there are more number of powers of 2. So powers of 5 is less than powers of 2. Powers of 5 is less than powers of 2. Powers of 5 is less than powers of 2. If powers of 5 is less than powers of 2, how to solve this one? Step number 3. First it is a 5 power. So this will be 3n minus 2 is equivalent to 5a. 3n equivalent to 5a plus 2. 3n equivalent to 3a plus 2 into a plus 1. 2 into a plus 1. Divisible by 3, divisible by 3. This should be divisible by 3. That means a minimum value, it should be 2. 2 plus 1, it is 3. If a minimum, it is 2. 5 2s are 10. So the series will be 10 is the lowest number. 5 2s are 10. 3 4s are 12 minus 2, 10. 10 plus, it is divisible by both 3 and 4. So the series will be 10. 10 plus 15, 25. It is again 15 plus 25, 40. How many values k can take, which will give single power of 5? K can take from 0. And it can go for 15, 6 are 90. 90 plus 10, 100. So 0 to 6. There are 7 numbers which will give 1 power of 5. That 1 power of 5 will get attached with 1 power of 2 and it will give me 0. At the end, 3n minus 2 equivalent to 5a, 3n equivalent to 5a plus 2, 3n equivalent to 3a plus 2 into a plus 1. It is divisible by 3, it is divisible by 3, a minimum it is 2. What is step number 4? Step number 4. Step number 4 will be 3n minus 2 equivalent to, what is the next power of 5? 25. Next power of 5, 25. So this will be 3n equivalent to 25b plus 2. 3n equivalent to 24b plus b plus 2. 24b plus b plus 2. Now if you see carefully, 3n is a multiple of 3. 24b is a multiple of 3. That means b minimum should be 1. If b it is 1, then the form will be 25 plus LCM of 3 comma 25 into k. 3 comma 25 into k. So k can take either 0 or 1. 25. 25 contains 1 power of 5. Here also we took 25 is 5 square. Here 1 power we took, here another power we took. I got 2 values. Here I got 2 values. Step number 3. Step number 3. What is the next number? 125c. 125 I cannot take. 125 I cannot take. Why? Because it is ending at 100. I hope the idea it is clear. So here 7 values, here 2 values. Totally 9 number of zeros will be there at the end. 9 number of zeros will be there at the end. I hope this idea it is clear. First thing is, check what is the nth term of the given series. Step number 2. Power of 5 is less than power of 2. So power of 5 form will be 5 power k into a. Because 25 can give extra powers of 5, 125 can give extra powers of 5. I only took till 25b. Next it is 125, but the upper limit for the question is 100. So this is not possible. Step number 1, step number 2, step number 3. Idea clear, right? Next one. Next question. These are a very, very important question. This we will solve it very, very fast. 1, 4, 7, 10, 13, 16, and so on up to 481. Step number 1. Tn equivalent to a plus n minus 1 into 3. So Tn is equivalent to 3n minus 2. N can range from 1 to 160, 480 minus 2, 478. 161. 161 is 3 into 161, 483 minus 2, 481. So n can range from 1 to 161. Step number 2. Step number 2. 3n minus 2 is equivalent to 5a. From here I will get one answer. Step number 3. 3n minus 2 equivalent to second 5 square 25b. I will get one more answer. Step number 4. 3n minus 2 equivalent to 125c. I will get one more answer. Next 5 power 4, 625. That is exceeding the upper limit. Just once you understand the flow chart, it is very easy. So this will be equivalent to 2 plus 5a. 3n equivalent to 3a plus 2 into a plus 1. That means a minimum will be 2. If a minimum, if it is 2, then the lowest value will be 10. This number is divisible by LCM of 3, 5 into k. K value can range from 0 to 15 3s are 45, 15 2s are 30, 0 to 30, 32 if I take 15 into 32, 480, 480 plus 10, it is 481. So it will take till 31, 0 to 31, 32 values it is there. 32 values. 10, next is the 10 plus 15, 25, 25 plus 15, 40, like that. All these are multiples of 5. Each one will give 1 power of 5. Next one. 3n minus equivalent to 25b plus 2. 25b can be written as 24b plus b plus 2. 24b plus b plus 2. This is a multiple of 3, multiple of 3. So b plus 2 should be a multiple of 3. B minimum value, it is 1. If it is 1, this will be 25 plus LCM of 3, 25 into k. So k value can be 0. 325, they are co-prime numbers. Co-prime LCM is their product. 75 6 are 450. Plus 25, 475. K value will be from 0 to 6. 7 values. Next one, 3n equivalent to 125c plus 2. So this will be equivalent to 123c plus 2 into c plus 1. Divisible by 3, divisible by 3. C minimum will be 2. If it is 2, here it will be 250 plus LCM of 3, 125 into k. So k value can be 0. K value can be 1. K value 2, 375, 2s are 750. 2 values. So 32 plus 7 plus 2. I hope this logic is crystal clear to you. Seems like a complex question, but actually it's a very easy question. The powers of 5 are less than powers of 2. So only I will show attention on powers of 5. Power of 5, it is less than power of 2. Power of 5, it is less than power of 2. Power of 5, it is less than power of 2. This is the step-by-step process to solve the question. I hope the idea it is clear. Next one. 2, 6, 4, 10. Same model, only the nth term it is different. Find the number of trailing zeros. The series is given in arithmetic progression. Step number 1. Tn equivalent to a plus n minus 1 into d. 2 plus n minus 1 into 4. So this will be 4n minus 2. Check it out whether 4n minus 2 is the nth term. N value 1, 4 minus 2, 2, n value 2, 8 minus 2, 6, n value 3, 12 minus 2, 10. Tn is 4n minus 2. Step number 2. N value can range from 1 to 125, 4s are 500 minus 2, 498, 126, 4s are 504 minus 2, 126. N value can range from 1 to 126. Step 2. 4n minus 2 is equivalent to 5a. I am sure you can solve this equation same like that. Step number 2. 4n minus 2 equivalent to 25b. Step number 3. 4n minus 2 equivalent to 125c. 625 we cannot take. 625 we cannot take. 3 problems, same model, so that it will be clear to you. 4n equivalent to 5a plus 2. 4n equivalent to 4a plus a plus 2. Divisible by 4, divisible by 4. A minimum, it is 2. 2 plus 2, 4. It is divisible by 4. 5 2s are 10. So this will be 10 plus LCM of 4 comma 5 into k. K can be 0, 24. Why it cannot be 25? 20 into 25, 500. 500 plus 10 is 510. Upper limit is 502. 0 to 24. Second case, 4n equivalent to 25b plus 2. 4n equivalent to 24b plus b plus 2. Divisible by 4, divisible by 4. B minimum will be 2. So it is 50 plus LCM of 4 comma 25 into k. K will be 0 to 100. 5s are 500. 500 plus 50. 550. 0 to 4. 4n equivalent to 125c plus 2. So this will become 124 plus c plus 2. Divisible by 4, divisible by 4. C minimum should be 2. So 2 plus LCM of 4 comma 125 into k. K can be 0 or 1. 0, 1, there are 2 values. 0 to 4, there are 5 values. 0 to 24, there are 25 values. Idea clear? I hope the idea it is clear. Idea it is clear. These are some of the very, very good questions. You are going to learn some wonderful questions in trailing zeros session number 2. Tn equivalent to a plus n minus 1 into d. First, the entire centralized idea is power of 5 is less than power of 2. That is the reason I am just checking the powers of 5. 5a, 25b, 125c. Remaining it is 625. Upper limit is 502. Good questions. Please try to solve it. See this question, sir. See this question. Find the number of trailing zeros. I want the number of zeros at the end. In the multiplication of these also we discussed in session number 1. 201 into 202 into 203 and so on up to 300. 201 into 202 into 203 till 300. If the question is not in factorial, I need to make it into factorial. How to make it into factorial? Multiply the numerator and denominator by 1 to 200. So this will become 201, 202 till 300. Denominator will be 1 into 2 into 3 till 200. So this answer will be 300 factorial divided by 200 factorial. Factorial number of zeros at the end is dependent on the power of 5. So 5 60s are, 5 12s are, and 5 2s are 74. So the numerator it is 5 power 74 into K1. Denominator it will be 5 40s are, 5 8s are, 5 1s are. It is 5 power 49 into K2. 74 minus 49. Answer will be 25. If the question is not in factorial format, make it into factorial format. How to make it into factorial? Multiply the numerator and denominator by that number which will result in factorial in the numerator and denominator, which will result in the numerator in factorial in numerator and denominator. Very, very good question. I hope you understood how to solve the problems if the factorials are not given. Next one, another question. Oh, these also a level 3 question, sir. Already we discussed it. Let me write down that key point. What are the key points that we discussed? We discussed it in session number 1. Session number 1. 1 factorial till 4 factorial. Number of trailing zeros. Number of trailing zeros. 1 factorial to 4 factorial. There will be no 5s. So number of trailing zeros will be 0. Number of trailing zeros will be 0. Similarly, 5 factorial till 9 factorial. 5 factorial, the number of trailing zeros will be 1. The same it will be there for 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9 factorial. So 1 into 5, I will get it. Similarly, from 10 factorial till 14 factorial, 10 factorial, whatever the number of zeros are there, the same thing will be there till 14 factorial. 10, it will be 2. So it is 2 into 5. 2 into 5. 15 factorial till 19 factorial. 5 3s are 15. So the number of trailing zeros for every number will be 3. 5 numbers are there. So it is 3 into 5. 3 into 5. 20 factorial till 24 factorial. It is 4 into 5. 25 factorial till 29 factorial. 25 it is 5 square. There is a jump of 2. It is 6 into 5. 30 factorial till 34 factorial. It is 7 into 5. Next it is 35 factorial. It is 1 5 I will get. 1 5. Till here it is clear, right? So this will be 8 into 1. Only 35 factorial it is 1. Number of zeros at the end will be 8. Is this idea clear? This is what we did it. Now the question is 1 factorial into 2 factorial into 3 factorial into 4 factorial into 5 factorial till 9 factorial into 10 factorial till 14 factorial. I hope you are understanding why am I writing like this. 15 factorial till 19 factorial. 20 factorial till 24 factorial. Into 25 factorial till 29 factorial. Into 30 factorial till 34 factorial. Into 35 factorial. Whole square the question is given. Whole square the question is given. Now easily one more step you will get the answer. There are no 5's here out. 5 factorial into 9 factorial. 1 into 5. So there are 5 5's are there. 10 factorial into 14 factorial. There are 2 5's are there. 2 5's are there, like that 5 numbers are there. 5 numbers are there. That means it is 5 square into K1 5 square into K5. So 5 times it is added. So it is 10. I'm sorry, sir. Next one, 15 factorial till 19 factorial. How many are there? 3. So it is 3 into 5. 20 factorial, it is 4 into 5. 25 factorial, how many I got? 6 into 5. 30 factorial, it is 7 into 5. 35 factorial, it is 8 whole square. It is whole square. Now, if you see here, now if we write like this, this is 5 power 1 into K1. It is 5 power 1 into K5. So, how many times? From 5 factorial, it is 5 times we got. So, these are all. It is 5. These are all like this. Yes or no? From 5 factorial to 9 factorial, 5 power 1 into K1, 6 factorial, 5 power 1 into K2, 9 factorial, 5 power 1 into K5. From 5 to 9, there are 5 5s are there. So this will be addition because of 5 powers. Don't do this silly mistake. That is the reason I am writing it. So it is 5 power 5 into 5 power 2 into 5 into 5 power 3 into 5 into 5 power 4 into 5 into 5 power 6 into 5 into 5 power 7 into 5 into 5 power 8 whole square. So this will be 5 power 10 plus 5, 15, 15 plus 15, 30, 30 plus 20, 50, 50 plus 30, 80, 80 plus 35, 115, 115 plus 8, 123. 5 power 123 power 2, 5 power 246. Answer will be 246. Answer will be 246. Very, very good question, sir. So even if you add it, 35, 30, these 5, this will be 10, this will be 15, this will be 20, these 30, these 35. If you add it, 15, 30, 50, 80, 115, 115 plus 8, 123. Square is there, I will get 246. Instead of doing all this, just I wrote it like this. You can add all this. You have understood how to do this function, right? Once you understand this one, it is very, very easy, sir. Very, very easy. These kind of questions are coming regularly in your examinations. Why it is added? Because power functions, a power m into a power n is a power m plus n. A power m plus n. Suppose if the question is like this, 5 factorial into 6 factorial and so on up to 24 factorial power 3. Number of trailing zeros. How to write down the answer directly? Number of trailing zeros. Number of trailing zeros. 5 factorial into 6 factorial and so on up to 24 factorial power 3. Find the number of trailing zeros. Right, now see here, from 5 factorial till 9 factorial, there are 5 numbers are there. Each number will give one highest power of 5. Similarly, 10 factorial till 14 factorial, it is 2 into 5. You don't need to do anything. 5 into 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. Into the power. Simple. This is the answer. Because 15 factorial till 19 factorial. 15 factorial contains 3 powers of 5. 3 into 5. Next will be 20 factorial into and so on up to 24 factorial. I will get 4 into 5. So if I add it, 5 common, 1 plus 2 plus 3 plus 4. A power m power n will become m into n. 7 and 9, 10. 10 5s are 50, 50 3s are 150. How many trailing zeros will be there for this expansion? It is 150. Even it is not difficult, just with a little practice, you can solve it very, very easily. 65 factorial into 66 factorial and so on up to 80 factorial power 4. 65 factorial into 66 factorial and so on up to 80 factorial power 4. Number of trailing zeros. Number of trailing zeros. Let us find it out easily without doing step by step like in the previous problem. 65 factorial into 66 factorial and so on up to 80 factorial. First we will do 65 to 69. So 65, how many zeros are there? 65 will be 5 13s are, 5 2s are. It is 15 into 5. This will be 16 into 5. This will be 18 into 5. This will be 19. So answer will be 15 into 5 plus 16 into 5 plus 18 into 5 plus 19. I hope the idea it is clear. Don't do any silly mistakes. Avoid doing any silly mistakes. First find out the number of zeros at the end for factorial. 5 13s are, 5 2s are. 13 plus 2, 15. 65 will have 15. 66, 67, 68, 69. 15 into 5. Next multiple, extra 1 will come. 16 into 5. 70 to 75. 75 is a multiple of 25. Extra 2 will come. So 18 into 5. 80, it is 19. Similarly, if the question is 124 factorial till 130 factorial power 2. Power 2. It is this one and it is power 4. So into 4. Into 4. I hope you are understanding the logic. Idea is to reduce the number of steps. Idea is to reduce the number of steps. So anyway, answer will be, it is into 12. 124 factorial. 5 24s are. 5 4s are. 24 plus 4, it is 28. First one 28 I will get. 125. 125 is 5 cube. Extra 3 will come. That means 31. How many numbers it will come? 125, 126, 127, 128, 129. Into 5. Plus 1 more will come 32. I hope this answer it is clear. Is the answer clear? For 124 factorial, I will get 28 zeros at the end. 125 factorial. 125 will be 5 25s are, 5 5s are, 5 1s are. It is 31. 125 to 129, it is 31. Plus 130, it is 32. 28 plus 31 into 5 plus 32. Idea clear? Very, very easy question, sir. From 5 factorial till 9 factorial. It is 5, it is 6 and it is from 5 factorial till 9. It is 5 into 1. Extra 1 more will come. Extra 1 more will come. 2 into 5. Extra 1 more will come. Extra 1 more will come. But from 25, extra 2 will come. Are you all with me? I hope the idea it is clear. Idea, I hope it is clear. Let me do one more question. Mock created question, sir. 90 factorial into 91 factorial and so on up to 100 factorial power 12 divided by 70 factorial and so on up to 80 factorial power 10. How many trailing zeros are there for these number? Find the number of zeros at the end. Zeros at the end is called as trailing zeros. 90 factorial into 91 factorial and so on up to 100 factorial. We will do slowly, sir. First, 90 factorial till 94 factorial. Step number 1. We will do it for the smallest number. 5 18s are 90. 5 3s are 15. 18 plus 3, 21. So I will get 21. For 90, I will get 91, I will get 92, I will get 93, I will get 94, I will get. Then 95, there will be extra 1. 22 into 5. Are you all with me? Plus 100. 100 will be the 25 into 4. Extra 24 will come. This is into 12. This is number of zeros at the end. 10 power k will give you the number of zeros. 10 power. Similarly, the next one. These are, most of the students will leave these questions, but actually they are very easy questions. 70 factorial to 74 factorial. 70 it will be 5 14s are. And next one it is 2s are. So this will be 16 into 5. 70 to 74. 75 is a multiple of 25. So 18 into 5. 80. 80 will be one more than. It is 19 into 10. Into 10. So this will be 105. This will be 110. This will be 24. These 215. 215 plus 24. 239. And this will be, so 10 power 239 into 12 minus 16 5s are 80, 18 5s are 90, plus 9, 170 plus 19, 189, 189 into 10, 1890. Whatever the answer that you will get here, that will be the number of zeros. I hope the idea it is clear. The more and more questions you will solve under this variety, the more and more concepts you will find it beautiful. Very easily you can solve. Why it is 21 into 5? 92, 94. Why it is 22 into 5? 95 to 99. What it is? 100 factorial. Similarly, these 70 to 74, 75 to 79, and this will be 80. A power n is a power m into n. A power m into n. Good question. I hope you enjoyed solving these beautiful mock related question. Next one. Another one. We have to do it very, very slowly. Find the number of trailing zeros. Same thing we will do. 5 power 5 into 10 power 10 into 15 power 15 into 20 power 20. I will write it like this. 25 power 25. I will write it down. Then 30 power 30. 35 power 35. 40 power 40. And 45 power 45. I will write it here. 50 power 50. 50 power 50. These are all getting multiplied into. Very, very easy. So powers of 5, all are single powers. 5 1s are, 5 2s are, 5 3s are, 5 4s are. So powers will get added. 5 plus 10 plus 15 plus 20. 25 it is 5 square. So it is 2 into 25. Are you all with me? All are single powers of 5. All are single powers of 5. 30 plus 35 plus 40 plus 45. 50 it is 2 into 50. Why? Because 50 is 2 into 5 square. 25 it is 5 square power 25. All will get added. This is the answer. 15, 30 plus 20. It is 50. Here also it is 50. 50 plus 50, 100. 80 plus 70, 150. 250s are 100. So answer is 150 plus 100, 250, 250 plus 100, 350. Number of zeros. Is the idea clear? Very, very easy question. If you understand the idea, single powers of 5 are there. So all will get added. 25 it is 5 square. It is 2 into 25. Single powers of 5 are there. 50 it is 2 into 5 square. So it is 2 into 50. One is 50, another is 50, another is 150 and another is 100. Very, very good question, sir. Trailing zeros, session number 2. It is a very, very good class where level 3 questions we are going to discuss. I hope this idea, please write down, sir. Find the last 2 digits for, because we did that question. Let me find it out. Find the last 2 digits for 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial and so on up to 10 factorial. Find the last 2 digits for 1 factorial plus 2 factorial plus 3 factorial and so on up to 10 factorial. Anyway, unit digit we got it as 3. We are interested in finding the last 2 digits. 1 factorial it is 1, 2 factorial 2, 3 factorial 6, 4 factorial 24, 5 factorial 120. 5 factorial 120. Till here we will do, sir. So here it is unit digit, it is 33. It is 33. 5 factorial will be 5 into 24, 120. These 5 factorial. 6 factorial will be 6 into 5 factorial. So 6 into 20, it will be again be 20. Are you all with me? 6 into 5 factorial. 5 factorial, it is 120. So I am just doing the tens place. 6 into 2. Suppose I want 7 factorial. 7 into 2, it is 14. It is 40. 8 factorial. 8 fours are 32. It is 20. 9 factorial. 9 twos are 18. 10 factorial. 10 eights are 80. I hope you are understanding how am I doing the last 2 digits. 6 factorial is 6 into 5 factorial. So 5 factorial it is 120. 6 zeros are 0. 6 twos are 12. 7 factorial it is 7 into 6 factorial. 6 factorial last 2 digits is 20. 2 sevens are 14. 8 factorial, it is 8 into 7 factorial. 8 into last 2 digits it is 40. 9 factorial, 9 into 8 factorial. 9 into 20. Are you all with me? 80 plus 20, 100. 140, 160, 180. 180 plus 33. Last 2 digits of these factorial sum is 13. Last two digits for this factorial sum is 13. Is the idea clear? 1 factorial it is 1. 2 factorial 2. 3 factorial 6. 4 factorial 24. 5 factorial 120. What are the last 2 digits of 120? 20. 6 factorial. 6 into 2, 12. 20. 7 factorial. 7 into 20. 140. 40. 8 into 40, 20, 9 into 20, 80, 10 into 80, 00, 80 plus 20, 100, 140, 160, 180, 180 plus 33, 213. Last 2 digits of this question, it is 13. I hope the idea, it is clear. Next one. 4 into, 8 into, 2 and so on. This method already we did it. 4 ones are 4. 4 twos are 8, 4 threes are 12, and so on up to 4 125s are 500. 4 125s are 500. So this will become 4 is multiplied 125 times 4 power 125 into 1 into 2 into 3 and so on up to 125. So this will be 4 power 125 into 125 factorial. Factorial numbers, number of zeros at the end is dependent upon the highest power of 5. 5 25s are, 5 5s are, and 5 1s are. So 25 plus 5 plus 1. Answer for this question is number of trailing zeros will be 31. Number of trailing zeros will be 31. 4 1s are, 4 2s are, 4 3s are, 4 125s are. 4 power 125 into 125 factorial. 125 it will be 5 25s are, 5 5s are, 5 1s are. 31. So number of zeros will be 31. Idea clear? It's this question, various models we already discussed. Finds the tens place of these expression. Tens place of these expression. From 10 factorial till 50 factorial. 10 factorial till 50 factorial. Last two digits will be 0, 0. Why? Because 10 factorial, it will give you number of zeros. Number of zeros at the end, two zeros. So, last two digits from 10 factorial will be 0, 0. 10 factorial will be 0, 0. Now, what we will do is, just now we did a similar question. 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. 5 factorial, 7 factorial. Don't solve it like this. Now, see this approach, sir. It is 1. These are all easy values. 6 plus 24. 5 factorial, it is 120. 120. 6 factorial, 6 into 20, 120. 7 factorial, 7 into 20, 140. 8 factorial, 8 into 40, 320. 9 factorial, 9 into 20, 80. 9 into 20, 80. Just by looking at a question itself, you are getting the last two digits very easily. Why? Because 6 factorial is 6 into 5 factorial. 5 factorial, it is 120. Only the focus is on last two digits. 6 into 20, it is 720. Last two digits only focus. 7 factorial is 7 into 6 factorial. 7 into, only the focus is on last two digits. 7 into 20, 40. Idea clear? 80 plus 20, 100. This is 33. This is 40. And this will be 40. Last tens place, it is nothing but 1. Last 10 place, it is nothing but 1. Idea, it is clear? So, answer will be 13. Answer will be 13. Or other way to look at this question is, if you want the tens place, divide these number by 100. Divide these number by 100. So, this will be 1 factorial plus 2 factorial and so on up to 9 factorial divided by 100. 100 is 4 into 25. Till 4 it is perfectly divisible. 3 factorial, it is 6. 2 factorial 2. 1 factorial 1. 6 plus 2 plus 1, 9. 4 2s are 8. Remainder is 1. Answer when divided by 4, it should give a remainder 1. Like that also you can do. I hope the idea is clear. Tens place of any expression. If you want the tens place of an expression, divide these number by 100. If you want the tens place of any expression, divide these number by 100. If I divide it by 100, 10 factorial onwards, 2 zeros will be there at the end. Everything will wash off, because all are divisible by 100. 100 is 4 into 25. From 4 factorial, all are divisible by 4. 25, just check it out, 25, where all it will be divisible. Suppose if you take 25, 6 factorial is 720. 25, it is not divisible. 7 factorial is 5040. You can check it out. Otherwise, divide it very naturally. Another just tens place is divide these number by 100. This idea, it is very clear, sir. This idea should be clear. 20 factorial, 21 factorial. Already, we did a lot of questions based upon this model. N is 20 factorial into 21 factorial and so on up to 33 factorial power 3 factorial. This is the question. 20 factorial, 21 factorial and so on up to 33 factorial power 3 factorial. Already we did it. 20 factorial till 24 factorial. There are 4 zeros at the end. 5 numbers will be there. 25, it is 5 square. So there will be a jump of 2. it will be 6 into 5. 30 factorial till 33 factorial, there will be one, how many numbers? 30, 31, 32, 33. 4 numbers, 7 into 4. 7 into 4. So answer will be 4 into 5 plus 6 into 5 plus 7 into 4 into 3 factorial. A power n will become a power m into n. A power m into n. Is the idea it is clear? From 20 to 24, there are 4 zeros at the end. There are 5 numbers. 25 to 29, there are 6 zeros at the end. There are 5 numbers. 30 to 33, there are 7 zeros and there are 4 numbers at the end. A power m plus n. So this will be 5 power 4 into 5 plus 5 power 6 into 5 into 5 power 7 into 4 power 6. So that is the reason addition came. That is the reason addition came. Next one. If the product has 68 trailing zeros, very, very important concept, sir. Please write down this concept. Key point. Key point. N factorial ends with x zeros. If n factorial ends with x zeros, then n should be greater than 4x. If n factorial ends with x zeros, then n is greater than 4x. I have discussed this proof in highest power concept, but I'll discuss it again. Now, number of trailing zeros. Listen carefully, sir. Number of trailing zeros. Number of trailing zeros for n factorial is given by highest power of 10 in n factorial. 10, it can be further optimized into highest power of 5 in n factorial. 5 in factorial, number of zeros at the end is given by the highest power of 5. Number of zeros at the end is given by the highest power of 5. Are you all with me? We have done so many problems. Suppose 100 factorial ends with dash number of zeros. 100 factorial ends with dash number of zeros. 100 first I divided by 5. 5 20s are 100. 5 4s are 20. 20 plus 4 is 24. Same is the case if I do it vertically. First I divided 100 by 5. Then I divided 100 by 25. Whatever I got, that itself is the answer. 100 by 5 is 20. 100 by 25, it is 4. That means, how to get the number of zeros at the end for factorial? First divided by 5. Then divided by 5 square. Then divided by 5 cube. Keep on dividing it till you cannot further divide. Suppose if n is 75, 75 by 5, 75 by 25, you cannot further divide. If n is 1000, 1000 by 5, 1000 by 25, 1000 by 125, 1000 by 625, these keep on dividing will stop at a point depending on the value of n. These n by 5 square. Why? Because for a factorial problems, number of zeros at the end is dependent on the power of 10. Power of 10 is dependent on the power of 5. Why? Because when you are writing 10 natural numbers product, 5 will come in the 5th place and 10th place. 2 will come in 2nd place, 4th place, 6th place, 8th place, 10th place. Power of 2 will be greater than the power of 5. So, these value will be stopping at a point. Can I say that 1 plus 2 plus 3 is always less than 1 plus 2 plus 3 and so on up to infinite? So, if I equate this series with an infinite series, this sum finite series is always less than infinite series. n by 5 square, n by 5 cube, and so on up to infinite. So if I take n by 5 common, this will be 1 plus 1 by 5, 1 by 5 square, and so on. So this will be x is less than n by 5 into 4 by 5 by 4. 4x is less than n. N is greater than 4x. Extremely important key point, sir. Very, very important key point. What is the relationship between number of zeros at the end and the factorial? N factorial ends with x zeros. Relationship between n and x is n is greater than 4x. N is greater than 4x. From where we got n greater than 4x? For a factorial, number of zeros at the end is dependent on the power of 5. So divide 100 with 5 and 5 again. So this 4 is dividing by 5 square. Am I right? So depending upon the value of n, this is a finite series. Finite series is always less than infinite. So this will be x is less than n by 5 plus n by 5 square, n by 5 cube, and so on up to infinite. So n will be greater than 4x. Very, very important key point, sir. Please write down. Please write down. Now, let us solve this question. Once you understand this concept, it is just a 1-minute job to solve our question. Let us solve this question. What is the question? If the product 1 into 2 into 3 and so on up to n. 1 into 2 into 3 till n, it is an n factorial. It has 68 trailing zeros. So, what is the concept? N factorial ends with 68 zeros. N factorial ends with 68 zeros. If n factorial ends with x zeros, what is the relation between n and x? N is greater than 4x. 4 into 68. N is greater than 4 8s are 32. So n is greater than 272. N is greater than 272. What is the multiple of 5 just greater than 272? 275. So this will be 5 55s are, 5 11s are, 5 2s are. That means 66, 68. N lowest value. N lowest value which will satisfy this condition will be 275, and n highest value will be 275, 276, 278, 279. Till 279, number of zeros will not change. Very, very easy question. N factorial ends with x zeros. N is greater than 4x. N is greater than 272. What is the multiple of 5? Just greater than 272. 275. Already we discussed from the multiple of 5 till the number which is just before the multiple of 5. Number of zeros will not change. Lowest value will be 275. Highest value will be 279. So the maximum value it can take is 279. All these are possible. Highest will be 279. Highest will be 279. Very, very important key point. The relationship between a number which is in a factorial format and the number of zeros at the end is given by n is greater than 5x. Y equivalent to became less than. It is a finite series. It's an infinite series. Finite series is always less than infinite. Finite series is always less than infinite. I hope the idea it is clear. Suppose if the question is n factorial ends with 17 zeros. N factorial ends with 17 zeros. What is the maximum value n can take? Another sample question. N factorial ends with 17 zeros. What is the maximum value n can take? N is greater than 4x. That means n is greater than 68. What is the multiple of 5 greater than 68? 70. So 5 14s are 5 2s are. 14 plus 2 is 16. I want 17. Take the next multiple. 5 15s are, 5 3s are. 75 is a multiple of 25. So there will be a jump from 16 with 2. 16 to 18 there will be a jump. How many values n will take? Such that n factorial ends with 17 zeros. What will be the answer? No value x takes. No value x will take, which will satisfy this equation. N is greater than 4x. N is greater than 68. We are working with factorial numbers. In factorial numbers, number of zeros at the end is dependent on the power of 5. So check for the multiple of 5. 70, I got 16. Next multiple of 5, 75, I got 18. Why there is a jump from 16 to 18? 75 is 25 into 3. So extra 2 will come. Extra 2 will come. I hope this concept it is clear to you. Next one. 55. 55th question. Already we have done enough number of questions of this model. So this is 3 1s are 3, 6 is 3 2s are, 9 is 3 3s are, 12 is 3 4s are, 360 it is, 3 120s are. So this will become 3 power 120 into 120 factorial. Number of trailing zeros in factorial is dependent on the power of 5. 24 plus 4. Number of trailing zeros will be 28. Number of trailing zeros will be 28. I hope it is clear. 3 power, it's of no use to us. 120 factorial, it is 5. Answer is 28. Next one. Already we did similar question. We already solved it. Similar question already solved. We have done enough questions of this model. 1 into 4 into 7 into 10 into 13. Next one. Find the number of trailing zeros of this number. Trailing zeros is only digit at the hundreds place. Digit at the hundreds place. Now see here. Listen carefully, sir. Units place, tens place, hundreds place. That means third digit from the right. I want third digit from the right. I want third digit from the right for this expression. Third digit from the right. Right. First digit is unit digit. Second digit is tens place. Third digit it is hundreds place. Third digit from the right. Now see here. This can be written as 2 power 80 into 5 square into 3 power 100 into 7 power 93 into 11 power 111. These can be written as 2 power 78 into 3 power 100 into 7 power 93 into 11 power 111 into 2 square into 5 square. 2 square into 5 square. 2 into 5, 10. 10 square last 2 digits, it will be 0, 0. 10 square last 2 digits will be 0, 0. That means I need to find the unit digit of this number. I need to find the unit digit of this number. How to find out the unit digit of this number? Use the cyclicity 4. 4 into 19 plus 2. 4 into 25. 4 into 23 plus 1. 1 power any number, it will be 1. So what is the concept for the cyclicity? A power 4k plus 2. It is a square. A power 4k, it is a power 4. A power 4k plus 1, it is a. Already we discussed a good number of sessions related to finding the unit digit of a number. related to finding the unit digit of a number. So this will be 4. A power 4, 3 power 4, 81 into 7 into 1. Digit at the hundreds place, it is 8. Another very, very good question, sir. 4 power 40 into 5 square into 3 power 100 into 7 power 93 into 11 power 111. 1 power any number, it is 1. 2 square I took it out and 5 square I took it out. 2 square into 5 square is last two digits, it is 0, 0. 78 is 4 into 19 plus 2. A power 4k plus 2, it is a square. So first is 4. 3 power 4 into 25, 1. 4 into 23 plus 1, it is 7. 1 power any number, 1. 4 sevens are 28. Unit digit will be 8. Unit digit will be 8. Please put a star mark on this question. It's a CAT replica question. It's a CAT replica question. Very, very good question. Where the last two digits are becoming 0, 0. Where the last two digits are becoming 0, 0. Next one, 57th over. N factorial is having 32 zeros at the end. How many values n can take? What is the concept? N is greater than 4x. What is x? Number of zeros at the end. So n is greater than 4 into 32. 4 32s are 128. N is greater than 128. Let me take the first multiple of 5 greater than 128. 130. 5 26 are 5 5s are 5 1s are 26 plus 6 32. So 130 factorial till 134 factorial. Number of trailing zeros will be same. Number of trailing zeros will be same. It is 32. How many values n can take? 130 factorial, 131 factorial, 132 till 134. Answer for this question will be 5. Answer for this question will be 5. N factorial ends with x zeros. N is greater than 4x. N is greater than 128. What is the multiple of 5 greater than 128? 130. 5 26 are 5 5s are 5 1s are. So it is coming out to be 32 zeros. So from 130 to 134, total 5 numbers have got 32 trailing zeros. If you know this concept, it is the 10 seconds problem, sir. If you don't know this, then you will find it very difficult. Next one, n factorial has 17 zeros. Already we discussed n is greater than 4x. 4 into 17. So what is the multiple of 5 greater than 68? 5 14s are 5 2s are 16. 17 will become 5 15s are 5 3s are 16 to 18. So answer is no value, it is possible. Please put a star mark on this question. 59th. Now another variety of questions. Read the question first. Read the question first. Which of the following cannot be the number of trailing zeros at the end of any one of the factorials? Which answer option cannot be the number of trailing zeros? Which answer option? Suppose if I take option 1. What is option 1? 48. N is greater than 4x. 4 into 48. N is greater than 192. N is greater than 192. What is the multiple of 5 greater than 192? 195. So this will be 5 3s are 5 9s are 5 7s are 5 1s are 5 1s are. I hope it is clear. So this will be 39 plus 6 plus 1. So this will be 47 zeros will be there. 47 zeros. Next multiple, it will be 5 40s are 5 8s are 5 1s are 40 plus 8 plus 1. 49 zeros are there. Am I getting 48 zeros anywhere? No, it is not possible. 49, it is possible. 47, it is possible. Suppose if I take next multiple, 205, 541s are, 58s are, and 51s are. 49 plus 1, 50. All these three are possible. First option, it is not possible. First option, it is not possible. I hope the idea, it is clear. Very, very good quality question, sir. Next one. See here. Next question. Which of the following can be the number of trailing zeros? Previous question is cannot be. Now it is can be. First option. First option. Option 1. N is greater than 4x. 4 into 63. N is greater than 252. N is greater than 252. What is the multiple of N greater than 252? 255. 551s are, 510s are, and 52s are. 51 plus 10, 61 plus 2, 63. It is possible. Suppose if I take option 2, N is greater than 4x, 4 into 68. So this will be N is greater than 272. What is the multiple of 5 just greater than 272? 275. 5 5s are 25. 5 5s are, it will be 5 11s are, and it is 5 2s are. 66 plus 2, 68. These also possible. Two options are possible. So answer will be all of this. There is no option 1 and 2 or option 2 and 3. If 2 are possible, answer will be all of this. Let us check it out. Option number 3. N is greater than 4x. 4 into 74. So this will be 296. What is the multiple of 5 greater than 296? 560s are, 512s are, and 52s are. 74. It is also possible. Option 4. It is 80. N is greater than 4x. 320. 325. 563s are, 512s are, 52s are. 565s are it is. 513s are, 52s are. 80. Option 1, 2, 3, 4 possible. N factorial ends with x zeros. Then the relationship between n and x is n is greater than 4x. 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 Any other question? Now this, we are at 61, right? Yes. Then 62. Which of the following cannot be the number of trailing zeros? So it is just by using answer options. Option 1. N is greater than 4x. So this will be N is greater than 112. What is the multiple of 5 greater than 112? 115. 523s are, and 5 4s are. 5 4s are. 27 I am getting, but I want 28 zeros. Next is 120. 5 24s are, and 5 4s are. 28. It is possible. First one, it is possible. Second one. Very, very interesting topics are it is. N is greater than 4x. N is greater than 4x. So this will be N is greater than 144. What is the multiple of 5 greater than 5? 29s are. 5 5s are. 5 1s are. It is 29 plus 5, 34. 34 plus 1, 35. Let me take the next number. 5 30s are. 5 6s are. 5 1s are. Anyway, 150 is a multiple of 25. 2 jump will be there. So this will be 35 to 37. 36 will not be possible. 36 will not be possible. I hope it is clear. n is greater than 4x is the concept. N greater than 144. Multiple of 5 greater than 144 is 145. So this will give you 35 zeros. 150 it is 25 into 6. Extra 2 I will get. So next will be 37. Second one will be the answer. Next one. N factorial ends with 24 zeros. N is greater than 4x. N is greater than 4 into 24. N is greater than 96. Multiple of 5 greater than 96. So 5 20s are 100. 5 4s are 20. So 24 zeros. That means from 100 factorial till 104 factorial, how many trailing zeros will be there? 24 trailing zeros will be there. Trailing zeros means the number of zeros at the end. Number of zeros at the end. Answer will be 5. How many values n can take? 5 values n can take. What are that 5 values? 100 factorial to 104 factorial. 100 factorial to 104 factorial it will take. Next one. N factorial never ends with. N factorial never ends with. Suppose if I take option 1. What is option 1? N is greater than 4x, 20. Multiple of 5 greater than 20. 5 5s are 25. 5 1s are 5. 5 plus 1 it is 6. 25 it is 2 powers of 5, sir. Previous it is 4. From 4 to 6. 5 it can never end with. There is no factorial which will end with 5 zeros at the end because of n greater than 4x concept. N factorial ends with x zeros. N is greater than 4x. N is greater than 4x. Idea clear? Next one. 64th question. Listen carefully to this question, sir. Solution. N plus 1 factorial has 3 more trailing zeros than n factorial. N plus 1 factorial can be written as n plus 1 into n factorial. Into n factorial. Read the question. N plus 1 factorial left hand side got 3 more trailing zeros than n factorial. That means 3 more trailing zeros is because of these n plus 1. 3 more trailing zeros are because of these n plus 1. The difference in the number of trailing zeros for n factorial and n plus 1 factorial is 3. That 3 is because of these n plus 1. 3 more trailing zeros. That means I should have 5 power 3 into k. K is not equivalent to. K is not equivalent to 5 powers. 5 multiples. K is not equivalent to 5 multiples. Because if k is equivalent to 5, I will get 4 more trailing zeros. How many 3-digit numbers are n can take? How many 3-digit numbers 100 less than or equivalent to, n less than or equivalent to 999? How many 3-digit numbers n can take? So n plus 1 is giving you 3 more trailing zeros. So it has to be of the form 5 cube into k. K is a natural number. K is a natural number. Listen carefully, sir. So n plus 1 can be 125 into 1. N plus 1 can be 125 into 2. N plus 1 can be 125 into 3. N plus 1 can be 125 into 4. N plus 1 can be 125 into 5, it should not be 6. N plus 1 can be 125 into 7. N plus 1 can be 125 into 8. Why? Because n will become 999. Listen carefully, sir. Listen carefully. Beautiful question it is. n plus 1 factorial has got 3 more trailing zeros. So it is n plus 1 into n factorial. These n plus 1 is giving you 3 more trailing zeros. 3 more trailing zeros means 10 power 3. To get 10 power 3, it should have 5 power 3. That means n plus 1 should be a multiple of n plus 1 should be a multiple of 5 cube into k. K cannot take. Let me take, if n plus 1 is 125, n will become 124. Let me check it out. 124 plus 1, 125 factorial. And this is 124 factorial. So 124, how many zeros will be there? 5 24s are, 5 4s are. 125, how many will be there? 5 5s are, 5 1s are. It is 31 and it is 28. Extra is 3. Definitely yes. Let me check it out by taking one more number. N plus 1, it is 250. If it is 250, n plus 1 is 250. That means n will become 249. This will become 250 factorial and this is 249 factorial. So 250 will become 5 50s are, 5 10s are, 5 2s are, 62 I got. 249 is 5 4s are, 5 9s are, 5 9s are, 5 1s are. So here it is 59, here it is 62. Very, very simple idea. N plus 1 should be a multiple of 125. Don't give multiple as another 5. Why? Because it will result in 4 more trailing zeros. 125 into k. How many multiples of 125 are there which are a 3-digit number? 125 ones are, 125 twos are. 1 possible, 2 possible, 3 possible, 4 possible, 6 possible, 7 possible, 8 also possible. Why? Because n plus 1 is 1000. N will become 999. That is possible. Are you all with me? Very, very good question. Very, very good question. Please put a star mark on this question. Extremely interesting question. Very, very interesting question. N plus 1 will take multiples of 125. Let us do one more question. Try to solve this question. Read the question, sir. N factorial. N factorial is written as n into n minus 1 factorial. N factorial has 2 more trailing zeros than n minus 1 factorial. Left hand side has got 2 more trailing zeros. 2 more trailing zeros. That means n should be a multiple of. N should be a multiple of. N should be a multiple of 5 square into k. 5 square into k. K cannot take multiples of 5. K cannot take multiples of 5. Are you all with me? 2 more trailing zeros, right? 2 more trailing zero means 10 square. 10 square means I should get 5 square. So it is 5 square into k. It is 5 square into k. So I should get 25 into k. 25 into k. How many 3-digit values n can take? N can range any value from 100 to 999. N can range any value from 100 to 999. Listen carefully, sir. 100 means k can take 4. Yes or no? K can take 4. Can k take 5? Not possible. Can k take 6? Yes. 7? Yes. 8? Yes. 9? Yes. 10. Is it possible? 10 means here 5 square, here 5. 5 cube I will get. 11? Yes. 12? Yes. 13? Yes. 14? Yes. 15. Is it possible? No. Is it possible? No. So instead of writing like this, k can take, first thing, from 4 to 13, 9. Am I right? Why? Because if k is 40, what is 25 into 40? 1000, but it should be a 3-digit number. So K will take 36 values. In that one, which all we should omit? K should not be a multiples of 5. 5 we should omit, 10 we should omit, 15 we should omit, 20 we should omit, 25 we should omit, 30 we should omit, 35 we should omit. 3, 6, 7. 36 minus 7, 29. You don't need to do this step of wasting your time. N should be a multiple of 25. N should be a multiple of 25. K cannot be a multiple of 5. So K can take 4, 5, 6, 7, 8. K actual range is, if I exclude that condition, K can take from 4 to 39, because 25 into 40 will get 1000. From 4 to 49, K cannot take multiples of 5. 5 ones are, 5 twos are, 5 threes are, 5 fours are, 5 fives are, 5 sixes are, 5 sevens are. 36 7 cases are eliminated. 36 minus 7, it is 29. Next one. P is a natural number. P ends with, suppose, see here, the best way to solve this question is take values, This method number 1. Suppose if I take P as 100, read the question first. P as 100. P is a natural number. I can use any natural number. P factorial ends with Y trailing zeros. 100 factorial ends with 24 trailing zeros. Ends with 24 zeros. It is clear. So these Y. Then the number of zeros, 5P factorial. 5P factorial means 5 into P, 500. 500 factorial. 500 factorial ends with how much? 500s are, 520s are, 54s are. That means this plus this will get added. This plus this will get added. What is 100? It is P. 24, it is Y. Answer is P plus Y. Answer is P plus Y. Are you all with me? This is a traditional method. Because P is a natural number, you can substitute any value. I substituted P equivalent to 100. 100 factorial ends with 24 zeros. How we got 24? 5 20s are, 5 4s are. 20 plus 4 is 24. 24 zeros it will have. 5P will become 500. 500 factorial will have 100 plus 20 plus 4. 100 is P, 24Y. Or otherwise, P factorial ends with Y trailing zeros. What is the concept to find out the trailing zeros? I need to divide by successively by 5. First Y, I will divide by 5. Then I will divide by 5 square. P by 5 square. Then I will divide by P by 5 cube. This will stop at a point depending upon the value of P. Then the number of zeros, 5P factorial. If it is 5P factorial, number of zeros, if I call it as Z. 5P factorial, 5P by 5. 5P by 5 square. These for 5P factorial. 5P by 5 cube. And so on. Are you all with me? Number of trailing zeros for P is P by 5, P by 5 square, P by 5 cube. For 5P will be. Now if you observe, listen carefully, sir. 5P by P, it is P. 5P by 5 square, it is P by 5. P by 5 square, and so on. So answer is Z equivalent to P plus 5. Very, very easy question. Z equivalent to P plus 5. How to find out the number of trailing zeros? Divide it successively by 5. So p by 5, p by 5 square, p by 5 cube. What if 5 becomes 5p by 5? How the answer number of zeros will solve? Z equivalent to 5p by 5, 5p by 5 square, 5p by 5 cube. P plus p by 5 plus p by 5 square. This entire expression, it is y. So answer is z equivalent to p plus y. Either you can take values or you can use this method. I hope the idea it is clear. Now another question. Another one. Read the question. N factorial ends with x zeros. Okay. N factorial ends with x zeros. N plus 4 factorial. N plus 4 factorial means either it can be n plus 4. Let me take all small. N plus 4 factorial. So this will be n plus 4 factorial is n plus 4 into n plus 3 into n plus 2 into n plus 1 into n factorial. Into n factorial. N plus 4 factorial. N factorial is ending with x zeros. Okay. Next question. N plus 4 factorial. N plus 4 factorial ends with x plus 3 zeros. N plus 4 factorial ends with x plus 3 zeros. That means this is ending with x zeros. N factorial, it is ending with x zeros. N plus 4 factorial, this is ending with x plus 3 zeros. Same question, we did it 15 minutes before. These ending with x zeros, these ending with x plus 3 zeros. What is the conclusion? That means extra 3 zeros. Extra 3 zeros came from above. Came from above. Am I right? So extra 3 zeros came from either n plus 1 or n plus 2 or n plus 3 or n plus 4. So case 1. If n plus 1 is 125. Yes or no? It can take 125k, right? So it can take 125 ones are, 125 twos are, 125 threes are, 125 fours are, 500. N plus 1 takes 500. N value will be 499. N is ranging from 1 to 500. Possible. Case 1. Or it can be because the 3 zeros can come because of n plus 2 also. It can be 125. It can be 250. It can be 375. It can be 500. Yes or no? N value can be 498. Or that 3 zeros can come from any one out of the 4 options. N plus 3 can be 125, 250, 375, 500. 500. If it is n less than or equivalent to 800, I would not have taken. K should not be a multiple of 4. Or what is case number 4? Case number 4 is n plus 3 can take 125, 250, 375 and 500. And 500. Now see here. And 500. I hope the idea it is clear. Let me do with example what is happening here. N plus 4 factorial it is n plus 4 into n plus 3 into n plus 2 into n plus 1 into n factorial. Into n factorial. Listen carefully, sir. Case 1. What is case 1? n plus 1 is 125. n plus 1 is 125. If this is 125, this is 126, this is 127, this is 128. This is 124. Factorial. This will be 128 factorial. Are you all with me? 124, 128. 124, 128. Now see here. If I take 128 factorial, 5 25s are, 5 5s are, 5 1s are, 31 zeros are there. 124 if I take, 5 24s are, 5 4s are, 28. 3 extra zeros I got. Yes or no? Or it can be 250, 251, 252, 253. It can be 375, 376, 377, 378. Are you all with me? 125 fours are 500, 501, 502, 503. N value will be 124, 249, 374 and 499. How many cases? 4 cases. This is case number 1. This is case number 1. What is case number 2? If n plus 2 is 125, this will be 124. This will be 123 factorial. This is 126, 127 and it is 128 factorial. Try to check it out. 128 there are 31. 123 it is 5 24s are 5 4s are. 28 31. I hope it is clear. This can be 250. This can be 375. This can be 500. Again 4 cases. Now I think I am sure it should be clear. If n plus 3 is 125, 124, 123, 122 factorial, this is 126. Again it is 126 factorial. 122 to 126. 122. 122 will be. Anyway, 123 number of zeros will be same. Again it will be 3. I hope it is clear. So this will be 250, 375, 500. What is the last case? N plus 4 can be 125. I wrote it so that it will be clear. 125, 124, 123, 122, 121 factorial and 125 factorial. So here it can be 250, 375, 500. So total 4 here, 4 here, 4 here, 4 here and 4 here. What will be the answer? 16. Answer will be 16. I hope the idea it is clear. So it's very easy. 125, there are 4 multiples of 125. It can take any one out of the 4 cases. 4 into 4, 16. Idea is to tell you that how that value of n is changing. How that value of n is changing. Is it clear? I hope it is clear, right? So 4, 4, 4, 4, total 16. Analyze this question, sir. It's a beautiful question. Directly it is 16. Now, directly we will write, sir, n plus 3 factorial. This question we will not do that much. It is n plus 3 into n plus 2 into n plus 1 into n factorial. N factorial contains x zeros. This contains x plus 3 zeros. This contains x plus 3 zeros. That means extra 3 zeros. Extra 3 zeros came from any one out of the 3 numbers. Extra 3 zeros can come from any one out of the 3 numbers. 3 zeros means it should be 5 cube into k. 125, 250, 375, 500. K should not be a multiple of 5. Otherwise, I will get 4 more zeros. 125 ones are, 2s are, 3s are, 4s are. 625, it is not possible. 750. 750. That means n plus 1. N plus 1. If it can be either 125 or 250 or anything. How many cases I got? 5 cases. This can take, this can take, this can take. Yes or no? 5 cases. 125 into 5. 625 case, don't take it. 625 case, don't take it. I hope the idea it is clear. Level 3 question, sir. 69th question. Please write down a note. Write down a beautiful note, sir. Note. Note. 3 in base system 10. If I convert into base system 3, it is 1, 0. It is 1, 0 in base system 3. If I do 9 in base system 10, in base system 3, it will be 3 3s are 9, remainder 0, 3 1s are 3, remainder 0. 1 0 base system 3. Listen carefully to this interesting point, sir. 3 power 1 in base system 10. In base system 3, it is 1 0. 3 square in base system 10. In base system 3, it is 1 0. 3 power 3 in base system 10. In base system 3, it is 1 followed by 3 zeros. Write down this point. Number of trailing zeros. Number of trailing zeros. In base system K, number of trailing zeros. In base system K, it is the highest power of K. It is the highest power of K. Very, very important point. Very, very important point. The number of zeros in base system K, it is 3. This is the highest power of 3 in base system 10. Highest power of K in base system 10. In base system 10. Suppose if I take a number which is in non-decimal, I convert into, if I take a number which is in decimal, convert it into non-decimal. Number of zeros at the end is nothing but the power of that base. Power of that base. 3 square. So number of zeros at the end will be 2. Now, the question is, find the number of trailing zeros. 100 factorial. 100 factorial in base system 10 is converted into base system 6. If 3 is converted into base system 3, how many zeros are there? 1 0. So this question is as equivalent to writing highest power of 6 in 100 factorial. Highest power of 6 in 100 factorial. I hope the concept it is clear. 100 factorial is converted in base system 6. Very, very interesting question, sir. Most of the students think that it is a difficult question, but actually it's an easy question. 100 factorial is converted in base system 6. 3 in base system 10. If I convert into base system 3, it is 1 0. 3 square in base system 10. If I convert into base system 3, it is 1 0. 100 factorial in a base system 10. If I convert into base system 6, the number of zeros at the end. Number of trailing zeros. Number of trailing zeros. Number of zeros at the end. Number of zeros at the end is the power of 3. What is the 3? Base. Number of zeros at the end is the power of 3. What is the 3? Base. Number of trailing zeros is the power of highest power of that base. Highest power of 6 in 100 factorial. Highest power of 6 in 100 factorial. 6 can be written as 2 into 3. 100 factorial. It is 2 power 97 into 3 power 48 into K1. So this will be 2 into 3 power 48 into 2 power 49 into K1. Answer will be 48. Very, very good question. He is just confusing you by giving you this question. This question is actually nothing but highest power of 6 in 100 factorial. Highest power of 6 in 100 factorial. Suppose if the question is 150 factorial is converted in base system 7. 150 factorial is converted in base system 7. It is nothing but highest power of 7 in 100 factorial. Highest power of 7 in 100 factorial. Answer for this question will be 24. Answer for this question will be 24. I hope the idea it is clear. Very, very interesting question, sir. Number of zeros at the end in base system K is the highest power of K. Number of zeros at the end in base system K is the highest power of K. 150 factorial, if I convert into base 7, zeros at the end is equivalent to the highest power of 7 in 100 factorial. I hope the idea it is clear. Next one. Oh, easily you can solve. Now see here. Concept. Number of trailing zeros. Number of trailing zeros. It is the highest power of 10. Highest power of 10. 10 it is 2 into 5. 2 into 5. When you are writing the number, 2's will come more than 5. So answer we took it as n is greater than 4x. N is greater than 4x. Am I right? The same thing here. N factorial ends with 20 zeros in base 21. In base system 10, I took 2 and 5. In base system 2, 1, it is 3 into 7. So 3's are more compared to be 7. So the relationship is n is greater than 6x. N is greater than 6x. So n is greater than highest power, highest prime power minus 1 into x. Highest prime power minus 1 into x, where base k can be written as P1, P2 and P3. Highest prime power will be the maximum of P1, P2, P3. Very, very interesting concept, sir. Highest prime power. Suppose in base system 10, 10 is 2 into 5. So n is greater than 4x. Because power of 5 will be less than the power of 2. In a base system 21, it is 3 into 7. Power of 7 will be less than power of 7. Same thing you will do. N by 5 square we did. N by 7, n by 7 square we will do. Very, very easy. This is a mock question which I created some years before. N factorial ends with 20 zeros in base 21. K is 21, which is 3 into 7. What is the maximum value of 3 and 7? 7. So n is greater than 6x. N is greater than 120. What is the multiple of 5? I took it because highest is 5. What is the multiple of 7 greater than 120? 126. 7 18s are, 7 2s are. 18 plus 2, 20. So 126 2. Till the next one number less than the multiple of 10. How many values? 7 will take. This is a very interesting question, sir. So, can I correlate the question in base system 10 to base system 21? In a base system 10, the number of trailing zeros is given by the highest power of 10. 10 is 2 into 5. 10 is 2 into 5. So based on 5, I got the relationship 4x. In 21, it is 3 into 7. How you got n greater than 7? 6x x equivalent to n by 7 plus n by 7 square, n by 7 cube, and so on. And so on. So x is less than n by 7 common, same thing. So in a base system 21, what is the relationship? N is greater than 6x. N is greater than 6x. Now see here, in a base system 10, n factorial ends with x zeros. N factorial ends with x zeros. So 10 is 2 into 5. So n is greater than 4x. This is the relationship. If it is, for example, 21 is 3 into 7. N is greater than 6x. N is greater than 6x. In a base system 6 is 2 into 3. 5 became 4. 7 became 6. N is greater than 2x. N is greater than 2x. I hope the idea it is clear. These are some very, very interesting questions on base system. Now, n factorial ends with x zeros, n greater than 4x. Some other base, how to solve? How to find out the number of trailing zeros? All these questions, we discussed this. Trailing zeros, session number 2. It is an advanced